Hello guys, in this video I'm going to be showing you how to simulate the Whitworth quick return mechanism in SolidWorks. I have all the models ready, so all I'm going to be doing is assembling all these different parts together and showing you the end simulation. You can also download all the parts that were used in this simulation using the link in the description. So I'll just show you the end result right now. So I'm going to play this simulation. So this is what you'll be learning how to do at the end of this video. So I'll just go to File, click on New, and select Assembly. Now I'm going to be inserting all the parts that I need. I have all the parts that I need open. So I'll just be inserting all these parts from the Insert Components menu. So the first part is going to be the fixed part. And then I'm going to be inserting all of the required parts by left clicking on the part and left clicking in the workspace. So I'll just do that now. Once I'm done inserting all of these parts in the workspace, I will start assembling them together. So I'll just insert all of these parts now. So once I'm done, I'll just start assembling the parts together. So the first part is going to be this one, and I'm going to be assembling it on the fixed part like that. It's a concentric mate. The next thing I'm going to do is I'm going to be doing a coincident mate on these two sides, or rather I'll do a distance mate of 2 mm. Now the next one is I'm going to be, let's see, I'll take this one and then assemble it into this part here. So this is going to be concentric. So as you can see, this has been inverted to the other side. So I'll just flip it by editing this feature. So there you go. And now I'm going to be doing a coincident mate on these two faces. So there, that is done. And now I'm going to be doing a mechanical mate, a slot mate on these two parts. So go to mate, and then at the bottom you will be seeing a mechanical mate. So go there, select slot, and select these two faces of these parts. So now you'll have a slot mate between these two parts. And the next thing is I'm going to assemble this part with, let's say, the center one of this part. It's going to be a concentric mate. Once that's done, we'll also do a coincident mate between these two parts so they don't move out of alignment. Once that is done, we have two more parts that need to be assembled. So that part is the part which reciprocates. So I'll just move it a little bit into alignment using the right click, and then I'm going to be doing a concentric mate between these two parts. So that's concentric. And then again I can do a coincident mate between these two parts. So that's done. One thing that needs to be taken care of is that this part can only move in one direction. So I'll need to constrain the other two directions. So let's just be 65 millimeters. Now the only part that needs to be assembled is the driving gear. So as you can see, the mechanism works as it is right now. Now for the simulation, we'll be using a motor in this small gear. So I'll need to assemble this part. with the coincident mate, and I'll also need to be doing a concentric mate so that it stays in position. For this, what I'll be doing is I'll be creating a circular sketch approximately where the gear needs to be, and then assemble the gear onto the circular sketch. So I'll just do an approximate circle here, and, and that'll be a circle. What I need to make sure is, since I'm going to be assembling this gear onto this sketch should not depend on the gear. So make sure you delete all those relations, and then drag and place the sketch at approximately the right spot that you need it to, so that the gear does not interfere with the larger gear when it is moving. So now I'm going to be doing a concentric mate to the sketch from the small gear. So that you've done, just make sure that the gear does not hit. Just make sure there is no interference before we start the motion simulation, and you can hide the sketch now. So once that is done, we can actually go to motion study and begin the motion simulation. Now we can start the motion study by creating a motor, and that motor is going to go to the axis of the small gear. Let's just say that it rotates at 30 RPM. Once that is done, I can actually move the slider to increase the time, and we are going to simulate contact between the smaller gear and the larger gear. Similarly, we are going to simulate contact between the larger gear and the slot. So I'll do that. Just create a contact group between the larger gear and the slot. Once that is done, you can actually calculate the motion. Once you've ensured that it is set to motion analysis, and now you have the actual simulation. Now you can click on play, and now you can see that the actual simulation is running. And also guys, one more thing I'd like to show you is how you could plot the velocity of any given point in this mechanism with respect to time. So you can do the following, and then you can select magnitude and select any point on the mechanism where you need the velocity to be plotted over time, and then click on OK. Now as you can see, the linear velocity of that point over the period of 6 seconds has been plotted on this screen. So that's about it guys. Thank you so much for watching, and I'll see you in the next video.